What if a moon smaller than Texas could hide an ocean beneath its icy crust, spewing plumes of water and organic molecules into space? The Cassini probe found evidence of hydrothermal activity, possibly a habitat for life, on this frozen world. Cassini's cameras first locked onto Enceladus's south pole in 2005. Not the expected frozen wasteland, but a fractured landscape glowing faintly under Saturn's rings. Long, parallel scars cut the ice, tiger stripes, sharp and dark against the snow. Then the plumes. Jets of vapor and ice particles erupting violently into the void, visible as shimmering curtains against the black sky. Cassini flew directly through them, sensors recording the impossible: water vapor, sodium chloride crystals like sea spray, and tiny silica nanograins. Salts dissolved in a hidden ocean, not frozen solid. The plumes fed Saturn's E-ring, a vast, diffuse band of ice particles encircling the planet. Cassini traced their source backward, confirming the moon's surface was a mosaic of ancient, cratered highlands and astonishingly young, smooth plains near the South Pole. Few craters. The ice was geologically new, forged by ongoing heat. The tiger stripes pulsed, venting material at a staggering 200 kilograms per second, enough to fill a large truck every second. Most escaped into space, seeding Saturn's rings. Some fell back as fresh snow, hundreds of meters thick. Cassini's instruments detected molecular hydrogen, a clear chemical signature of hydrothermal vents deep in the ocean. Tidal forces from Saturn's gravity churned the water, heating it. Silica grains confirmed superheated water interacting with rock at the seafloor. The ocean wasn't just liquid, it was active, chemically dynamic. Phosphates, later identified in E-ring grains, hinted at the fundamental building blocks for life. Enceladus, a world barely 500 kilometers across, concealed a hidden ocean where life's ingredients swirled in perpetual darkness, vented into the cold vacuum by a tiny moon's stubborn heartbeat. The plumes carry the ocean's secrets into the void. Cassini flew through them, measuring salts, silica nanograins, and molecular hydrogen. The hydrogen is a direct chemical fingerprint of hydrothermal vents interacting with rock. Silica grains confirm superheated water circulating through the seafloor. These are not incidental findings. They point to an active, heated environment beneath the ice, where chemistry brews far from sunlight. Phosphates, later found in E-ring snow, complete the picture. Life's essential building blocks exist in this hidden sea. Could the plume simply be melting ice? The moon's surface is frozen solid, far too cold for liquid water to form without deep heat. Cassini saw no evidence of melting ice at the surface. The tiger stripes' heat signature comes from below. The plumes erupt at 200 kilograms per second, more than a truck per second. Melting ice could not generate such sustained, energetic output. The energy source must be internal, deep within the moon. What about cryovolcanic lakes? Some moons have surface ice melt, but Enceladus's ocean is global, not localized. Tidal heating from Saturn's gravity sustains the entire sea. The smooth South Pole, scarred by tiger stripes, shows recent geological activity. Craters are absent there. This isn't surface ice erupting, it's water from a deep ocean, pushed upward by pressure. The plume's composition matches hydrothermal activity, not simple ice melt. Hydrothermal vents explain the chemistry perfectly. Hot water dissolving minerals from rock creates silica and hydrogen. Earth-like microbes could thrive there. The plumes vent these chemicals into space. But why does Enceladus have such a rich ocean? Why this specific mix of organics and minerals? The vents are active, but the asterisk reason they exist, deep within a tiny moon, remains the question. The evidence points to life's ingredients flowing freely. Yet the mechanism that fuels this hidden heart still escapes us. Tidal heating powers the plumes. Saturn's gravity squeezes Enceladus, generating internal warmth. But this explains only how the ocean stays liquid, not why it vents such complex chemistry. Cassini measured silica nanograins and molecular hydrogen directly in the plumes. Earth's hydrothermal vents produce similar chemistry, but only through rock-water interaction at high pressure. Enceladus is a mere 500 kilometers across, smaller than France. Its core should be cold, yet it sustains a persistent global ocean. The scale defies simple models. Why does a tiny moon generate such intense, sustained chemical activity? Hydrothermal vents explain the detected chemistry. Hot water dissolving minerals create silica and hydrogen. The plumes match Earth's deep-sea vents in composition. Yet vents don't require the specific mix found. Phosphates were identified in earring grains, essential for DNA. Other icy moons like Europa show hydrothermal signatures but lack these phosphates. Enceladus ocean interacts intimately with its rocky core, producing organics and minerals in precise ratios. The vents exist, but their intensity asterisk, fueling a global ocean with life-essential elements, remains unexplained. Why this specific chemistry? Could microbes be the source? Cassini detected methane and complex organics, hinting at biological processes. Yet the same organics form abiotically in hydrothermal systems. No biosignature was found, only the raw ingredients. The plumes carry Earth-like molecules without microbial signatures. We see the ingredients, not the cook. Hydrothermal chemistry alone produces these findings. Life might be present, but the data cannot confirm it. The vents could be purely chemical. The ocean is global and interconnected. Tidal forces heat the entire moon, maintaining a 10-kilometer deep sea. Phosphates in earring grains prove the ocean dissolves minerals from the bedrock. Yet the power driving this system remains elusive. Saturn's gravitational pull alone shouldn't sustain such persistent, deep-seated activity in such a small body. The moon's internal structure, how heat concentrates, defies current models. We have the ingredients for life, but the engine that runs this hidden ocean remains a mystery. What fuels the heart of a moon smaller than France?